the triple bond containing molecules. There are not many ways to make them. I can tell you two different ways to produce them. One is using really simple alkyne, acetylene, the triple bond, with a hydrogen on those two triple bonding carbon. You can take the protons away, but you gotta use it very strong base. Alkoxide, oxygen negatively charged, is not going to be strong enough to do that. You have to use a more strong base. It's called the sodium amide. The sodium amide, that is a basic enough to take these protons away, so you get the carbon negatively charged. That's acetylene. That acetylene is a basic because we just take the protons off from the carbon, it's not acidic. So it's a pretty strong base, but at the same time, it's good nucleophile, but it's a pretty big nucleophile. So it can make a substitution reaction with an alkyl halide, that's based on SN2 reactions. But you remember that SN2 reactions are state hindrance very sensitive. So you better use something very small, like a primary alkyl halide. Secondary might be okay, but tertiary definitely no. I want you to remember that. But this is just nothing but SN2 reactions. So you can connect an alkyl chain to the triple bond carbon and then produce like that to introduce one of the alkyl chain on the one side of the triple bonds. If there's another hydrogen on the triple bonds available, then you can do this again. Treat the base one more time after the action. Then you can basically make another nucleophile again. And then you can react alkyl halide with it. Or I just want to mention that alkyl halide is not only the electrophile you could use, but also you can use the carbonyl, like ketones, aldehyde. Because the carbonyl, this double bonding carbon with an oxygen is electrically efficient because of the oxygen bounded. So that nucleophile can make an attack to this carbonyl, and then that will push one of the high electrons to go to the oxygens. So you're going to get the alkoxide produced in the beginning, but that will be taking the proton during the walk-up step. So based on the walk-up step, you just dump it into the water, then this get protonated, so you get alternation done on the triple bond. Especially these type of connections, when you see a carbon bound to triple bond having an oxygen there, alcohol like this, then you should suspect that this might be produced in this manner. So it's kind of giving you an idea that one ingredient you need to make this synthetic skin possible. So that's the one way. You can use the small triple bonds, you grow them to whatever you want by adding alkyl chain by the nucleophilic test. That's the one way. Second way is you can make a triple bond from the halide that done by the elimination reactions. So you need two pairs of the HBr or HCl because you need two elimination to get the triple bonds. So first elimination is nothing but E2 elimination reactions that makes double bonds. But after that, second eliminations are really hard because you need a really, really strong base and highly energetic strong base. So that would be the molten KOH in high temperatures, sodium amide, a strong base in high temperatures again. That basically makes a triple bond where they are, where the halogens bond. So